So let's continue with the problems. This is the third exercise of surface area and volumes. So here in this third exercise, we'll be converting one shape into another shape. Remember, whenever you convert one shape into another shape, the one thing that remains the same is the volume. Okay. Suppose you convert 3 to 4 spheres into one big sphere. Obviously, the space occupied by this first, second, third, fourth, the total space that will be equal to the space occupied to the bigger ball. Okay. So one thing, whenever you convert one shape into the other shape, the one thing that remains constant is volume. Okay. So now with that note, we'll start with the first question. A metallic sphere of radius 4.2 centimeter is melted and recast into shape of cylinder of radius 6 centimeter. So we have got a metallic sphere. Okay. What I'm drawing is not a sphere, actually it's a circle, but symbolically we are just representing this to be a sphere. Okay. So this is a metallic sphere which is converted into a shape of the cylinder. Okay. And you convert one shape into another shape, what remains same? As we discussed, the volume remains same. So here very clearly volume of sphere will be equal to volume of cylinder. Now let's write the dimensions. The metallic sphere is of radius 4.2 centimeter. Okay, let me take it as small r, 4.2, and capital R is the radius of the cylinder, which is 6 centimeter. What we have to find is the height of the cylinder. H is equal to question mark. Now, what is the volume of sphere given by 4 by 3 pi r cube? And here it is pi capital R square H. So both the sides we can cancel pi and pi. So what is left out? 4 by 3 r cube is equal to r square into H. Now 4 by 3 as it is, r is 4.2, so 4.2 cube, which means we have to multiply 3 times, 4.2 into 4.2 into 4.2. R square is 6, so 6 square into H we have to find it. Okay, so 6 square is 36, isn't it? So in the next step, we can cancel it. 3 ones are 3, 1 carry, it becomes 12, 3 fours are, so it becomes 1.4. Okay, so what we are left is 4 into 1.4 into 4.2 into 4.2 is equal to 36 into H. What we need is H, so let's transpose 36 to the other side. So it becomes 4 into 1.4 into 4.2 into 4.2, the entire thing divided by 36, that is equal to H. Okay, so here we can actually cancel 4 ones are 4 nines are 3 threes are 3 1.4s are, again 3 ones are 3 1.4s are. So all it becomes is 1.4 into 1.4 into 1.4. Okay, so if you multiply all this stuff, 1.4 into 1.4 is 1.96. So 1.96 into 1.4. Okay, so let's multiply 1.96 into 1.4. That becomes 2.744. So the height is approximately 2.74. Okay, so the units are given in centimeter. Therefore, this will also be in centimeter. So the height of the cylinder will be 2.74 centimeter. Let's get into the next question. Metallic spheres of radii 6 centimeter, 8 centimeter, and 10 centimeter. So we have got 3 spheres. Okay, 1, 2, and 3. Okay. So let's say this is sphere 1, sphere 1, sphere 2, and let's say this is sphere 3. Okay, so these 3 things are converted into what? A bigger sphere. Okay, they're converted into a bigger sphere. Remember, what remains same? The volume remains same, isn't it? Therefore, the volume of sphere 1, volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3, volume of sphere 1 plus volume of sphere 2 is actually equal to volume of bigger sphere, isn't it? Now let's take the volume of the sphere 1 as R1, which is 6 centimeter, R2 is 8 centimeter, and R3 is 10 centimeter. We have to find the bigger R. Okay. So volume of sphere is given by 4 by 3 pi R cube. For the sphere 1, it will be 4 by 3 pi R1 cube plus 4 by 3 pi R2 cube plus 4 by 3 pi R3 cube. That will be equal to 4 by 3 pi capital R cube. So in the LHS, you can take 4 by 3 pi as common. So what is left out? R1 cube plus R2 cube plus R3 cube. That will be equal to 4 by 3 pi R cube. 4 by 3 pi, 4 by 3 pi gets cancelled. R1 cube plus R2 cube plus R3 cube is equal to capital R cube. So R1 is 6 cube plus 8 cube plus 10 cube, that will be equal to capital R cube. Now 6 cube is 216, 8 cube is 512, and 10 cube is 1000. That will be equal to capital R cube. Okay. So 216 plus 512 will be 728 plus 1000 is 1728. So 1728 is equal to R cube, which implies R is equal to cube root of 1728. So how do we find cube root? By prime factorization method itself. So 2 8s are 16, 1 carry, 2 6s are 12, 2 4s are 8, 2 4s are 8, 2 3s are 6, 2 2s are again, 2 2s are 4, 2 1s are 2, 2 6s are 12. Okay. Again, it goes by 3, 3 7s are, 3 2s are, 3 2s are, 3 4s are, 3 8s are, again by 2, 2 4s are, 2 2s are, 2 1s are. So since it is cube root, make a group of 3 members. This is one group, this is one group, this is one group. From each group, we have to take one number, okay, and multiply all those. 2 3s are 6, 6 2s are 12. So therefore, the cube root comes out to be 12 centimeter. So this is the final answer. Okay. For square root, we have to make a pair. For cube root, we have to make a group of 3. Okay. So let's get into the next question. A 20-meter deep well with diameter 7 meter is dug, and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. Now let's say this is the ground level. Okay. Let's say this is the ground level. Now we are gonna that is, we are gonna dig a well, something like this. So we have dug a well here. Okay. The dimensions of the well are given. The height is 20 meter. The height of the well is 20 meter, and the diameter is 7 meter, which implies the radius is 7 by 2 meter. Now, whatever the mud was there, okay, by digging this, you get some mud, right? That mud is used in making a platform. Now, if you remember, platform is actually cuboidal in shape. Let's take a platform something like this. Okay. The platform looks something like this, isn't it? The platform is actually like this. So which is a cuboidal in shape. Which is cuboidal in shape. Let me redraw it. Something like this. isn't it? The platforms look something like this. So the length of the platform is given, the breadth of the platform is given. The length is 22 meters, okay, and the breadth is 14 meters. What we have to find is this height, okay, height of the platform. That is what we have to find. Now, whatever the earth or the whatever the mud that we got by digging is used in making the platform, okay. So in other words, the cylindrical shape is converted into cuboidal shape, isn't it? Therefore, we can say that volume of cylinder, okay, volume of cylinder is actually equal to volume of cuboid, okay. Now, where the length of the cuboid is given as 22 meter and the capital B, the breadth of the cuboid is given as 14 meter, we have to find h, okay, the height of the cuboid. So volume of cylinder is given by the formula pi r square h, and volume of cuboid is capital L into capital B into capital H. So pi is 22 by 7, r is 7 by 2 the whole square, so r is 7 by 2, so r square will become 7 by 2 into 7 by 2 into h, h is 20 meters. Length is given as 22 meters, breadth is given as 14 meter. We have to find the value of h. So here 7 and 7 gets cancelled. 2 ones are, 2 tens are, again 2 ones are, 2 fives are. So what we are left is 22 into 7 into 5 equals 22 into 14 into h. So we need h, we don't need this 22 and 14. Let's transpose the other side. 22 into 7 into 5 divided by 22 into 14, that is equal to h. 22 gets cancelled. 7 ones are, 7 twos are. So we have got 5 by 2. What is 5 by 2? 2.5. So the height of the platform is 2.5 meter. Okay. So that's the height of the platform that we get. Okay. So let's get into the next question. The next question, a well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly all around in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. Okay. Now, what we have got here is, this is the ground level. Okay. Now here we have dug a well. Okay. So we have got a well here. Okay. So this is the ground level. Okay. Now the depth of the well is 14 meter. That will be the height. Okay. And the radius is 3 by 2. The diameter is given as, let me take it as small d, which is 3 meter. The radius will become 3 by 2 meters. And let's take h, height of the well, okay, this, or let me take it as capital H, which is 14 meter. Okay. We have to find the height of the embankment. Let me take it as small h. Okay. Now, the embankment is something on top of this. Okay. The shape, it looks something like this. This is the ground level. Okay. Now on top of this, you build it on the top of this. Okay. So it will be something like this. Okay. Now this extended version. So on top of the well, you build something like this, that is called as the embankment. Let me also show you a picture for a clear information. Okay. This is how the embankment looks like. Okay. As you can see here, let me take a different color. So here you can see in the figure, this structure on the ground level, that is known as the embankment. Okay. Now, if you observe, the embankment is looking like a circular ring. Let me draw the top view. You got an outer version, okay, and an inner circle like this. And here you got stone, all the stuff, isn't it? This is how from outside it looks like. And this circle is the well, okay. Here also you can see that the outer version. This is the inner one and the outer one. So as you can see, there are two cylinders here. One is the bigger one, which is outside. The other one is the smaller one, which leads to the well itself, isn't it? It leads to the well itself. Now, let's find the height of the embankment. Let's take height of the embankment is this, from here to here, okay. Now, let me delete this for time being. I hope you understood what is embankment. Now, the mud that was taken out is used in making embankment, isn't it? So the volume of cylinder, okay, that is actually equal to volume of cylinder is actually equal to volume of embankment, isn't it? So we converted one shape into another shape. Therefore, we can say volume of cylinder is equal to volume of embankment. Now, volume of cylinder is given by the formula pi r square h, capital H. Okay. So pi small r square capital H. Okay. We have taken the capital H as the height of the cylinder, isn't it? Now, volume of embankment. Now, how do we find volume of embankment? See here in the center here, it is empty, right? This is empty. So volume of embankment is only this part, isn't it? Wherever the material is there. So how do we find volume of embankment? It is simply the outer cylinder. When I find the volume of outer cylinder, we get the entire thing. But the inner cylinder, we don't need it, isn't it? So therefore, volume of, let me make this a bit short. Okay. Volume of embankment. So volume of embankment is actually volume of outer cylinder, okay, minus volume of inner cylinder. There are two cylinders, two cylindrical structures, isn't it? Let me see, let us observe from the figure itself. From the figure itself, if you observe, let me put it up. Now here we need the volume of this embankment, isn't it? How do we find it? Let's find the volume of the outer cylinder. When I find the volume of the outer cylinder, we get the entire thing. Okay. Embankment is only the circular ring part. Okay. But in the middle, we don't have any embankment. It is open, right? Here, there is nothing. There is no material here. So we don't want that. So we have to subtract it. So that's why we have taken it as volume of the outer cylinder minus volume of the inner cylinder. Okay. The outer cylinder will have more radius compared to the inner cylinder. So outer cylinder will take it as capital R. Inner cylinder will take it as small r. Okay. Let me draw the top view. Okay. Only the top view. Okay. The smaller cylinder radius is actually equal to R itself because the same thing connects to the well, right? So whatever is the radius here, the same diameter and radius will be here, isn't it? Therefore, small r is this. Now, to find the capital R, we have to add this width, okay? And the width of the circular ring is given, it is 4 meter, okay? So the small r is 3 by 2 meter plus width. So capital R is actually equal to 3 by 2 plus 4. That becomes 11 by 2. If you take LCM, it is 11 by 2 meters. Okay. So on that note, let's solve it. Pi r square h The volume of the outer cylinder. See, when I say outer cylinder, I'm talking only about this. Okay. Only about the outer cylinder, this one. Okay. So pi will be the pi r square, that is capital R square, and h will be height of the embankment, which is h, small h, minus inner cylinder pi small r square small h. Okay. And for inner cylinder, remember, you're not supposed to take the entire one, only from here to here, isn't it? From this part till here, only so much. That is only the embankment. Below that it is well, right? So pi r square capital H. Here you can take pi as common, so capital R square H, or you can actually take pi H as common. So you will be left with capital R square minus small r square. Pi and pi gets cancelled. So we are left with r square H. R is 3 by 2. So 3 by 2 the whole square. H is 14 equal to small h, we have to find it. Capital R square is 11 by 2 the whole square. Small r square is 3 by 2 the whole square. So 3 by 2 the whole square will become 9 by 4 into 14, that is equal to h. 11 by 2 the whole square, 121 by 4 minus 9 by 4. Okay. So let us solve it here. So 9 by 4 into 14. 2 2s are 2 7s are. So 9 into 7 is 63. 63 by 2 is equal to h. 121 by 121 minus 9. That gives you around 112 by 4. So you can cancel it. 4 1s are, 4 2s are 8, 3 carry, it becomes 8. 4 8s are. Okay. So 63 by 2 transpose 28 to the other side equal to h. The 7 4s are 7 9s are. So h value will become 9 by 2 into 4 is 8. So this comes out around 1.125 meter. Okay. So the height of the embankment is around 1.125 meter. So the volume of the earth that was taken out is used for embankment. So volume of embankment, remember, it is found by outer cylinder minus inner cylinder. So let's get into the next question. We have got a container shaped like a right circular cylinder having 12 centimeter diameter and height 15 centimeter, is full of ice cream. So what we have got is a cylindrical shaped container, something like this, which is full of ice cream. Okay. So it is full of ice cream. Okay. Let me represent it like this. Now the diameter is given as 12. So let me take D as 12 centimeter. So radius is 6 centimeter and the height is 15 centimeter. Okay. Now the ice cream is to be filled into cones of height 12 centimeter. So we have got cones whose height is 12 centimeter. So here let me take it as HCY. Here let me take it as HC, which is 12 centimeter, and diameter is 6 centimeter. So let me take this as capital D, the bigger one. Let me take this as capital R. So small d is 6 centimeter and R is 3 centimeter, having a hemispherical shape on the top. So we have to fill a cone, and obviously on the top you'll have something like this, isn't it? That's how the ice cream you have, isn't it? So the ice cream in this cylindrical container has to be filled like this. Okay. The question is, how many cone ice creams can you fill? Okay. The total number of, we have got 1 here. Okay. Actually, there are n number of cone ice creams. We have to find how many it is. Okay. That is the question. Find the number of such cones which can be filled with the ice creams. Now, whatever the ice cream is inside the cylinder, okay, the volume of it is actually equal to volume of the cylinder, isn't it? So volume of cylinder is equal to, we are filling it in the shape of cone plus hemisphere, isn't it? So volume of cone plus volume of hemisphere. Okay. If you had only one cone, you would have written it like this, but there are n cone. So throughout you have to multiply by n. Okay. So volume of cylinder is given by the formula pi capital R square capital H n into, let me take this as capital H, that will be fine. Okay. Let me take this as small h. Now n into volume of cone 1 by 3 pi small r square small h. Volume of hemisphere is 2 by 3 pi r cube. Okay. So here what we can take common, pi r square h is equal to n. We can take 1 by 3 pi r square as common. We'll be left with h plus 2r. Okay. So pi here and pi here gets cancelled. What is the value of capital R? It is 6. Capital R is 6. So 6 square will become 36. Capital H is 15. That is equal to n into 1 by 3 into r square. That is 3 square. H plus 2r. H is 12 plus 2 into r. 2 into 3 is 6. Okay. So this becomes 36 into 15 is equal to n into 1 by 3. 3 square is 9. 12 plus 6 is 18. So 3 ones are 3 3s are. So we want the value of n. So let's transpose everything to the other side. 36 into 15 by 3 into 18 is equal to n. So 18 ones are, 18 twos are, 3 ones are, 3 fives are. So 2 into 5 is 10. So totally how many cone ice creams can we fill it? We can fill 10 cone ice creams using the ice cream that is in the cylindrical bucket. So whatever ice cream was there, we have converted into this shape. So volume of this, that is volume of cylinder, is equal to volume of cone. But we don't have one cone, we have got n number of cones. That's why we have multiplied with n. And substituting the formula, you will get the answer. So let's get into the next question. How many silver coins 1.75 centimeter in diameter and of thickness 2 mm must be melted to form a cuboid of dimensions 5.5 centimeter into 10 centimeter into 3.5 centimeter. Basically, remember, if you compress a cylinder, we get a coin. Okay. Think of a 5 rupees coin. That will be a very good example. Let's draw it. Suppose you got a cylindrical shape. Okay. And if you compress it from both the ends, okay, we get a coin shape, isn't it? If you compress it from both the ends, you get a coin shape. The 5 rupees coin, that will be the best example. So let me draw it. I'm just drawing a rough diagram of a coin. Okay. So the coin is something which is in cylindrical shape. Okay. So they have given the thickness. Here the thickness will be acting as the height. Okay. Height is 2 mm. It's given in millimeter. We have to be very careful. Okay. Here all the SI units must be same. But everything is given in centimeter, but this is given in millimeter. Converting everything into millimeter will be a bit easy. Okay. We can remove all the decimal points if you convert. So let's keep the height in millimeter itself. Okay. The diameter is 1.75 centimeter. If you convert it into millimeter, it becomes 17.5 mm. Okay. So to convert centimeter into millimeter, you have to just multiply by 10. So the radius will become 17.5 divided by 2 mm. That's the radius of the coin. This coin must be melted and it should be converted into a shape of a cuboid. Okay. Now the dimensions of the cuboid is also given. Okay. You have to convert something into a cuboidal shape. So the dimensions is given. Capital L is 5.5 centimeters, so it becomes 55 mm. I'm converting everything into millimeter, and 10 centimeter will become 100 mm. Okay, and 3.5, the capital H, 3.5 centimeter will become 35 millimeter. Okay, because 10 millimeter is equal to 1 centimeter. Okay, so if you want to convert 5.5 centimeter to millimeters, you have to simply cross multiply 5.5 into 10. So it becomes 55. That's what we have done. Okay. So here we know that the coin shape, that is the cylindrical shape, is converted into cuboid. And we don't have one coin, we have number of coins. We don't know how many coins exactly we have. So let's take it as n. So n into volume of cylinder will be actually equal to volume of cuboid. Now n into volume of cylinder. Volume of cylinder is pi r square h. That will be equal to volume of cuboid is capital L into capital B into capital H. So n as it is, pi value is 22 by 7. R square. R is 17.5 by 2 the whole square. So I have to write it twice. 17.5 by 2 into 17.5 by 2 into H. H is 2. That will be equal to capital L into capital B into capital H. Capital L is 55. Capital B is 100 and capital H is 35. Okay. Now here we can cancel certain things. 2 and 2 gets cancelled. 2 ones are 2, 11s are 7 ones are 7 twos are 14. 3 carry 7 5s are 35. So it becomes 2.5. So what is left out? N into 11 into 2.5 into 17.5 equals 55 into 100 into 35. Therefore, n value, transpose everything to the other side, 55 into 100 into 35 divided by 11 into 2.5. 11 into 2.5 actually becomes 27.5. Okay, let me multiply directly. 11 into 2.5 is 27.5. Okay, into 17.5. Now, if you observe carefully, 17.5 ones are 17.5 twos are. If you double 17.5, you'll get 35, isn't it? Similarly, 27.5 ones are 27.5 twos are. Therefore, the value of n will become 2 into 100 into 2. 2 into 100 into 2 is how much? 400. So, how many coins should we melt? We must melt 400 coins to get a cylinder, sorry, to get a cuboid whose dimension is 55 mm, 100 mm, and 35 mm. So let's get into the next question. Cylindrical bucket 32 centimeter high with a radius of base 18 centimeter is filled with sand. So we have got a cylindrical bucket. Let's draw that. We've got a cylindrical bucket. So what is the radius? Radius is given as 18 centimeter and the height of the bucket is 32 centimeter and it is completely filled with sand. Okay, so it is filled with sand. Okay, let's proceed with the question. This bucket is emptied on the ground and a conical heap of sand is formed. So you are emptying this bucket on the ground. Okay, so definitely it will be kind of a conical shape. Okay, so we get a conical shape here, something like this. Okay, now if the height of the conical heap, okay, so let's take capital H to be the height of the cylinder and small h to be the height of the cone, which is 24 centimeter. What we have to find is the radius. So let's take this as capital R. Small r is the radius of the cone, which should be found, and we should also find the slant height. Now it's very clear the cylindrical shape is converted into the conical shape. So therefore, volume of cylinder is actually equal to volume of cylinder is equal to volume of cone. So volume of cylinder is given by the formula pi. We have taken capital R square, capital H. Volume of cone is 1 by 3 pi small r square, small h. So pi and pi gets cancelled. Okay. So capital R is 18. So 18 square into capital H is 32 equals 1 by 3 into small r square. We have to find it. And capital small h is 24. Okay. Here we can cancel it. 3 ones are, 3 eights are. So here let's keep this 18 square as it is into 32 divided by this 8. Let's transpose it. It comes to the denominator. Okay. That is equal to r square. So 8 ones are 8, 4s are. So 18 square into 4 is equal to r square. Therefore, r will become square root of 18 square into 4. Since they are in product, you can split it. That is, you can write it as square root of 18 square into square root of 4. So square and root gets cancelled. So we'll be left with 18. And square root of 4 is 2. So 18 into 2 is 36. So the radius of the cone is 36 centimeters. Okay. Now let's get into the next one, that is finding the slant height, the next part of the question. L is given by the formula square root of h square plus r square. So according to the question, the small h is 24. So 24 square plus r is 36. So 36 square. So 24 square is 576. 36 square, 900, 36, 360. Okay. So it will be around 1236, 1236. You can verify it. Okay. So 576 plus 1276. So it becomes 1300, 1800, 1812. Okay. I'm not sure about this. Let's first calculate the value of 36 square. 1296. I'm sorry. 1296 plus 576. That gives you 1872. Okay. Find the square root of 1872 using the prime factorization method. Okay. So you will get the answer. So let me find it using the help of calculator. 1872 square root. So we get it around 43.268 something. Here you will get in terms of roots. Okay. Or you can keep it as it is. So many centimeters. So let's get into the next question. Actually, after 7th one, we have directly taken the 9th one because once we solve 9th one, easily we can solve the 8th one. Okay. So farmer connects a pipe of internal diameter 20 centimeter from a canal, okay, into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If the water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? Here, what we have got as a canal, let's say canal something like this, or let me share the screen and show you how the canal looks like. So it looks something like this. This type of structure is called the canal. Okay. So the farmer connects a pipe from the canal. Let's simply represent. Okay. Let's take it like this, a canal. From this, a farmer connects a pipe, okay, of diameter 20 centimeter. From this canal is connecting a pipe. Obviously, the pipe is in cylindrical shape. This pipe is again connected to a cylindrical tank. Okay. This pipe is connected to a cylindrical tank like this. Okay. Let me draw it properly. Okay, something like this. Now, the dimensions of the pipe. Okay, the diameter is 20 centimeter, which implies R is 10 centimeter, the radius. The length of the pipe is not given. Okay. The height of the bigger tank is given as 2 meter. Okay. Let's take it as capital H. And the diameter is 10 meters. So the radius will become 5 meter. So this radius, which is in centimeter, let's convert into meters. So it becomes 0.10 meter. Okay. So 10 centimeter will become 0.10 meters. So everything is converted into meter. Now the question is, the water from the pipe is flowing towards the tank. Okay. Now what we have to do is we have to find the time that is taken to fill this tank. It is also given that the speed at which the water is coming out of the pipe is 3 km per hour. Okay. So this is in kilometer per hour. Let's convert it into meter per second because all other SI units are in meter. So let's convert this also in meter. So meter per second. Okay. So 3 into 5 by 18. That's how we convert. We have to just multiply 5 by 18 to convert it into meter per second. Okay. So many meter per second. Now, the volume of water coming out, from the pipe is actually equal to the volume of water in cylindrical tank, isn't it? Whatever the water comes out of this pipe, that water will be in the cylindrical tank, isn't it? So how much ever comes out, that will be in the cylindrical tank. So volume of water coming out of from the pipe, that will be equal to volume of water in the volume of water inside cylindrical tank. Now, the volume of water coming out from the pipe depends on three factors. One is area of the cross section. Remember, if this pipe is very, very big, okay, if the pipe is very, very big, that is area of cross section is big. Okay, I'm not talking about the length, the area of cross section. That is, if you have a pipe and if you cut it exactly perpendicular, okay, so the section that you get is called as area of cross section. If the area of cross section is big, we get more amount of water. If it is very, very small, we get only less amount of water, doesn't it? So the volume of water coming out of the pipe depends on the area of cross section, and also it depends on the speed and the time, isn't it? If the speed is more, if the tank fills more, I mean, it takes very less time to fill, or if the speed is more, we get more amount of water, isn't it? If the water is flowing very slowly, the amount of water that we get in a let's say in a dedicated time, in 5 minutes or 10 minutes, will be very, very less, isn't it? Suppose if the speed is very, very more, we get more amount of water, isn't it? In the sense, in 5 minutes we get more amount of water. Okay. And it also depends on the time, because if you allow the water to flow for more amount of time, you get more amount of water. Less amount of time, less amount of water, isn't it? So therefore the water coming out of the pipe depends on the area of cross section, area of cross section. It depends on area of cross section into speed and into time. That will be equal to volume of cylinder. Volume of cylinder is what? Pi capital R square capital H. Now area of cross section, pi, the cross section will be in circle shape. So pi small r square into speed into time, that is equal to pi capital R square capital H. So actually we can cancel the pi and pi here. Okay. So r square, the small r is 0.1 square. So 0.1 into 0.1. The speed is 3 into 5 by 18 into time. That is what we have to calculate. The time taken to fill the tank. Capital R is 5. So 5 square. Capital H is 2. Okay. So in the next line, 0.1 into 0.1 becomes 0.01. Okay. Into here, you actually cancel 3 ones are 3 6 are. So you'll be left with 5 by 6 into time. Pi square is 25. 25 into 2 is 50. Therefore, let's transpose everything to the other side. Time will be equal to 50. 6 comes to the numerator. Other things comes to the denominator. 5 into 0.01. Okay. So here actually we can cancel 5 ones are 5 10s are. So time is equal to 10 into 60 is 60. 60 by 0.01. So if you remove the decimals in the denominator, we have to put zeros in the numerator. So we have to, after decimal, you have got 2 digits. Therefore, if you remove the decimal, you have to put 2 zeros in the numerator. So 6000 by 1. 6000 by 1 is what? 6000 itself. Therefore, the time is equal to 6000 seconds, because the speed was in meter per second. If you divide by 60, you will get around 100 minutes. Okay. 6000 seconds is 100 minutes. So roughly around 1 hour 40 minutes. Okay. So remember, the volume of the water that is coming out of the pipe, that will be equal to area of cross section into speed into time. And it doesn't depend on the height of the pipe or the length of the pipe. Whether the pipe is smaller or bigger, It doesn't depend. Okay. Similarly, let's get into the next question. Water in a canal. Basically, the canal will be in cuboidal shape. Okay. So as you have seen the figure, okay, you had something like this, isn't it? So you'll have a length and you'll have the breadth. So this, let's take it as length, and this is breadth, and you'll also have height, isn't it? So it will be in cuboidal shape. So the water in canal 6 meter wide. So they have given the breadth is equal to 6 meter, and they have given the height, which is 1.5 meter, is flowing with the speed. So speed is also given as how much? 10 kilometer per hour, and it will irrigate. Okay, with the speed of 10 kilometer per hour. How much area will it irrigate in 30 minutes? So time is given in 30 minutes. Okay, 30 minutes. And if 8 centimeter of standing water is required. So if you take an area, a small place, okay. Now if you irrigate water, the water occupies cuboidal shape, okay, because now the area is a rectangle shape. On top of it, the water stands up to 8 centimeter. Okay, it will be something like this. So this amount of water, okay, the water will actually form a cuboidal shape, kind of a cuboidal shape. Okay, so this is the amount of water that has to stand on the field. Okay, so therefore, very clearly, volume of water from the canal, whatever the water is coming from the canal, that will be equal to volume of cuboid, isn't it? Because if you irrigate a land, the water occupies what shape? Cuboidal shape. Okay, so volume of water coming from the canal, we know that it depends on area of cross section. Okay, area of cross section into speed into time, and volume of cuboid is capital L into capital B into capital H. Now area of cross section, here it is B into H. Okay, basically if you take a canal, it is in cuboidal shape, and if you cut it perpendicularly, what you get, the area of cross section is B into H. Okay, the base or the breadth into height. Speed is 10 kilometer per hour. Let's convert it into meter per second. So it will become 10 into 5 by 18. Time is given in minutes, so I have to convert it into seconds. So let's here let's convert into seconds. So 30 into 60 equals L into B into H. So the area should be calculated. L into B is area, right? So let's write it as area itself. Height is 8 centimeter. So if you convert it into meter, it becomes 0.08. So let's cancel out things here. 3 6 are 3 10s are 6 1s are 6 10s are. So B and H value is given as 6 meter and 1.5. So 6 into 1.5 into 10 into 5 into 10 into 10 is equal to area. Let's get the 0.8 to the denominator itself. Okay. So if I remove the decimal, I have to place one more zero in the numerator. So let's make it as 60 into 1.5 into 10 into 5 into 10 into 10 divided by 8. That will be equal to area. Here we can actually cancel 4 2s or 2 4s, 2 5s, 2 2s, 2 5s, 2 1s, 2 5s. Okay. So this will become 60 into 1.5. 15 6 is 90. Okay. So 15 into 60 will become 900. So since point is there, it will become 90 into 5 into 5 into 5. That is 5 is 25, 25 5 is 125. That will be equal to area. 125 into 9. 9 5 is 45. 9 2 is 18. 9 1s are 9. 9 plus 2 is 11. Okay. So much meter square. Okay, that will be equal to area. Please verify this answer. Okay, I've roughly done it. 9 5 is 45. 5 4 is a carry. 9 2 is 18. 18 plus 4 is 22 is a carry. 9 1s are 9. 9 plus 2 is 11. Yeah. So much square. So with this, we have completed the third exercise also. In the next video, we'll start with the last exercise, that is frustum of cone. Thank you, students.